human existence is brief, fragile, and astonishingly small in the grand stage of the cosmos. We live our entire lives on a floating rock we call Earth, a mere leftover fragment from the formation of a relatively ordinary star we call the Sun. Even this Sun, which feels so central to our world, is a newcomer in cosmic history, having formed in the last third of the universe's timeline. When we consider that the Milky Way holds around 100 billion stars, many of which formed billions of years before our own, our place and our accomplishments appear almost embarrassingly modest. The universe has been around for nearly 14 billion years, shaping galaxies, birthing and extinguishing stars, and orchestrating cosmic events of unimaginable scale long before the first human learned to walk upright. In this context, our record as a species is far from impressive. We have barely stepped beyond our planetary cradle, and we have explored only a tiny sliver of the vastness that surrounds us. The cosmos is full of mysteries we have not yet observed, forces we do not fully understand, and phenomena that challenge the limits of what we think we know. This immense unexplored frontier should inspire humility rather than arrogance, curiosity rather than complacency. As long as we remain humble and open-minded, we can continue discovering new truths. But the greatest threat to knowledge is not ignorance. It is the arrogance of expertise. Expertise, when held too tightly, becomes a prison. It convinces people that their current understanding is complete, that no alternative explanation is worth entertaining, and that any idea outside their established framework must be dismissed. Recently, when I was interviewed by a group of 8 podcasters and reporters, including Gadi Schwartz on NBC News and Elizabeth Vargas on News Nation, they asked why so many comet experts are quick to reject any alternative interpretation of the strange anomalies associated with the interstellar object 3I/Atlas. To answer this, I made an analogy between unimaginative scientists and artificial intelligence systems. Both tend to respond in ways consistent with their training data. If an AI model is trained exclusively on images and data related to comets, it will insist that anything unusual in the sky is a comet, simply because that is all it has ever learned to recognize. In the same way, comet experts, whose entire careers are built on studying natural comets, are inclined to classify anything unfamiliar as just another comet, no matter how many anomalies stand in the way of that conclusion. This is precisely why scientists rushed to label 1I/Oumuamua as a dark comet. It exhibited a form of non-gravitational acceleration, yet it left no detectable gas or dust, no tail, no coma, no visible traces of sublimation that a normal comet would produce. The term dark comet became a convenient label to explain a behavior that did not match expectations. Meanwhile, objects like NASA's discarded booster 2020 SO or the Tesla Roadster launched by SpaceX behave in ways that resemble dark comets as well. They are smooth, reflective, light, and affected by solar radiation pressure, characteristics that can mimic comet-like acceleration. But these artificial objects are obviously technological in origin, and comet experts typically refuse to include such examples in their conceptual training data. Their worldview excludes the possibility that an interstellar object behaving unusually might be technological rather than natural, even when the evidence could reasonably warrant such a hypothesis. On top of this intellectual inflexibility, there is an instinctive, almost Pavlovian resistance to new ideas, a defensive reflex that protects established professional territory. When scientists have invested decades of work into a particular field, they can become emotionally and professionally attached to their interpretations. Any suggestion that challenges their framework feels like an attack on their accumulated knowledge, their reputation, and even their identity. This combination of rigid training and personal defensiveness explains why many comet experts so fiercely insist that the 7 jets recently observed around 3I/Atlas must originate from pockets of sublimating ice, rather than from thrusters or any technological source. To them, every problem must have a cometary solution, because that is the only toolbox they are willing to use. Fortunately, there is a healthier path forward, one rooted in evidence rather than ego. In the weeks leading up to 3I/Atlas's closest approach to Earth on December 19, 2025, we will have valuable opportunities to gather data that can test the competing hypotheses. We will be able to measure the speed, density, and composition of the emitted jets. These measurements can tell us whether the jets behave like natural outgassing or whether they resemble engineered propulsion. Likewise, we will look for multiple fragments produced during perihelion, which is precisely what we would expect if 3I/Atlas is a traditional comet breaking apart under solar heating. The approach is straightforward. Seek the data, analyze the measurements, and let the evidence guide the conclusion. When scientists approach a puzzle with curiosity rather than preconceived answers, the discovery process becomes a unifying force. It brings people together in a shared pursuit of truth. But when egos dominate, science becomes distorted by politics, social media noise, and personal agendas, driving people apart rather than inspiring wonder. These upcoming observations are not happening in isolation. On October 2nd to 3rd, 2025, the high-rise camera aboard the Mars Reconnaissance Orbiter captured side-view images of 3I/Atlas at a resolution of about 30 kilometers per pixel as the object passed roughly 29 million kilometers from Mars. These early images represent a first step in the investigative process, an attempt to document the object's appearance and behavior from a new vantage point. Following the acquisition of these images, an official letter was submitted to NASA requesting more extensive observations and analysis. The letter laid out the scientific rationale for examining 3I/Atlas with greater precision and transparency. After the letter became public, Congresswoman Anna Paulina Luna amplified the effort by sharing a message on social media, bringing greater attention to the case and encouraging increased public support for further investigation. Regardless of one's political views, the broader point remains. People from different backgrounds and roles in society can unite when curiosity, transparency, and the desire for truth take priority over personal biases or disciplinary turf wars. If we can maintain this spirit, curiosity without arrogance, inquiry without defensiveness, science will continue to flourish. The universe is vast, mysterious, and full of surprises. We have not been around long enough to claim mastery over its secrets, nor are we entitled to assume we already understand every phenomenon it presents. Interstellar objects like 3I/Atlas and Oumuamua remind us that the cosmos is under no obligation to conform to our expectations. Sometimes, the universe throws us something that does not fit neatly into known categories. When that happens, our task is not to force the anomaly into an old box, but to expand the box or build a new one. We should welcome surprises. They are the moments when science has the greatest opportunity to grow. No progress ever comes from clinging to old ideas simply because they are comfortable. Progress emerges when we acknowledge that the unknown exists, that our knowledge is incomplete, and that the universe may operate in ways we have not yet imagined. If we approach the mysteries before us with humility instead of arrogance, and with curiosity instead of fear, we stand a much better chance of uncovering the truth, whatever that truth may be. And ultimately, that is what science is all about, not defending the past, but exploring the future.